Hi everyone. Welcome to our facts. The ozone layer is a thin layer of ozone gas located in the stratosphere, approximately 10 to 50 kilometers above the Earth's surface. It plays an important role in protecting life on Earth by absorbing harmful ultraviolet, UV, radiation from the sun. The ozone layer is constantly being formed and broken down by natural processes, but human activities, such as the release of certain chemicals, have caused significant damage to the ozone layer over the past few decades. Here are 25 facts about the ozone layer. The ozone layer is made up of ozone, O3, molecules, which are composed of 3 oxygen atoms. The ozone layer is located in the stratosphere, which is the second layer of the Earth's atmosphere. Ozone is a highly reactive gas that is created and destroyed through a complex series of chemical reactions in the atmosphere. The ozone layer is thickest near the equator and thinnest near the poles. The ozone layer absorbs most of the sun's harmful UV radiation, preventing it from reaching the Earth's surface. The ozone layer is estimated to have formed about 2 billion years ago, shortly after the appearance of photosynthetic organisms that released oxygen into the atmosphere. The main chemical responsible for ozone depletion is chlorofluorocarbons, CFCs, which were widely used in refrigeration, air conditioning, and other industrial processes. Other chemicals that contribute to ozone depletion include hydrochlorofluorocarbons, HCFCs, halogens, carbon tetrachloride, and methyl chloroform. The use of CFCs and other ozone-depleting substances was largely phased out in the late 1990s under the Montreal Protocol, an international treaty signed by over 190 countries. The ozone hole is a large area of depleted ozone over Antarctica that forms each year during the southern hemisphere spring. The ozone hole was first discovered in the late 1970s by scientists who noticed a significant decrease in ozone levels over Antarctica. The size of the ozone hole varies from year to year, depending on factors such as temperature, wind patterns, and the amount of ozone-depleting chemicals in the atmosphere. In addition to causing ozone depletion, CFCs and other ozone-depleting substances are also potent greenhouse gases that contribute to climate change. Ozone depletion can lead to increased skin cancer rates, cataracts, and other health problems in humans and animals. Ozone depletion can also damage crops, reduce yields, and disrupt ecosystems. The effects of ozone depletion are most pronounced at high latitudes, where the ozone layer is already thin. UV radiation can penetrate the ocean surface and damage marine ecosystems, including phytoplankton, which are a key source of food for many marine species. Ozone depletion can also affect terrestrial ecosystems, including forests and grasslands. The recovery of the ozone layer is a slow process, as ozone-depleting chemicals can persist in the atmosphere for decades. The Antarctic ozone hole is projected to fully recover by the middle of this century, while the recovery of the global ozone layer is expected to take several more decades. Some countries, such as India and China, are still using ozone-depleting substances, which can slow down the recovery of the ozone layer. The ozone layer protects the Earth from harmful solar flares, which can cause disruptions to satellite communications and other technologies. The thickness of the ozone layer can be measured using instruments such as the Total Ozone Mapping Spectrometer, TOMS. Scientists continue to monitor the ozone layer and study its interactions with other components. Ozone depletion can also have economic impacts, such as damage to infrastructure, increased healthcare costs, and decreased tourism. The depletion of the ozone layer can lead to the formation of more ground-level ozone, which can be harmful to human health and contribute to smog. Some species of plants and animals may be more sensitive to UV radiation than others, and thus may be particularly vulnerable to the effects of ozone depletion. The depletion of the ozone layer can also affect the Earth's climate by altering atmospheric circulation patterns and temperature distributions. The use of alternative chemicals to replace ozone-depleting substances can also have environmental impacts, such as increased greenhouse gas emissions. The scientific understanding of the ozone layer and its interactions with other components of the Earth system continues to evolve, and new research is being conducted to better understand these processes. Thanks for watching. Subscribe please.